Thank you for joining us and exploring the cosmos with our community and beyond. The study of space includes entrepreneurship, biology, project management, finance, and much more, which is exactly what you find in our space studies degree here at American Military University and American Public University. Over the next 2 days, you will hear from many fascinating presenters. You will hear from professors, students, researchers, attorneys, including practitioners from a vast array of fields. It is fair to say that we will be among some of the most brilliant and influential minds in terms of space exploration, and for that, we are extremely proud. It's time to let the sessions begin. Thank you.
Brain-computer interfaces, or BCIs, hold significant potential for enhancing complex decision-making in space operations by improving both cognitive and physical capabilities. BCIs allow users to communicate external devices using brain signals rather than the brain's normal output pathways of peripheral nerves and muscles. Basically, the devices can perform direct communication with computers and control robotic systems without the need of physical interaction. Altering a human's bodily functions to meet requirements of extraterrestrial environments would be more logical than providing an earthly environment in space. But until technology advances, for now, merging BCIs with humans may be the only option for sustained space operations and eventual colonization within our solar system.
We were assigned with writing a research proposal in comparative planetology. I chose to propose the spatial comparison of water ice distributions on Earth and Mars. Analysis from 2004 concluded that the upper meter of Mars regolith may be more than 50% water ice. But if we wanted to go deeper, this 2016 study on the Martian northern plains was exhibiting some geomorphological features of subsurface ice. The goal of my research proposal is to look at the water distribution on Mars globally and comprehensively instead of these isolated patches by trying to leverage something we already know about water distribution by looking to the Earth as comparison.
Magnetism is at the heart of all solar activity, giving us space weather. Solar activity can affect Earth's magnetosphere via geomagnetic storms. This is especially important as we become a technology-dependent society and expand our space exploration efforts. What I wanted to find out is how the sun's magnetic field is generated. If you were to listen to the sun, it would sound like a constant humming noise, and that is because there's millions of wavelengths that travel throughout at the same time. The path of each wavelength reveals certain characteristics of the solar interior. All types of turbulent motion in a conductive fluid can create a dynamo to act as a magnetic field generator. Helioseismology bridged the gap between what scientists observed on the photosphere and the mechanisms involved within the interior. The cohesion of large-scale and small-scale dynamos shows the dynamic nature of our sun, with a multitude of forces, flows, and motions that participate. Heliophysicists, solar astronomers, and helioseismologists will continue to unify each piece in hopes of fully understanding the heart of all solar activity.
We're looking at communications between mission control, mission support, and the analog astronaut crew. We used the Echo communication system, and that system allows for us to communicate with the crew and allows for us to have a built-in time delay of 20 minutes. We were studying the effects on stress and how communication is effective or not. After our mission was over, we looked through the Echo transcript of the mission and we looked at the survey data to get an idea of how messages were being communicated, how effective communication was, and what stress levels crew and mission control were reporting. And we found that overall, mission control was 3.4 times as likely to have to ask for clarification. And something interesting that we found was that overall, on the mission control side, it was the exact opposite of crew. So mission control was pretty calm. They felt pretty good the entire time. And then crew definitely got more stressed during that time delay phase where we were dealing with a 20-minute delay each way.